For this video, we will look at Chapter 19, Worksheet 3. So what Worksheet 3 is about is that we are going to look at quadrilaterals now. What are quadrilaterals? Essentially, it just means any object with four sides or four vertices. Okay, so a very important thing to understand, if I look at what I mean by quadrilateral, any 2D shape with four sides and four vertices. So we have learned this in primary school as well. Sum of interior angles within a quadrilateral is 360 degrees. And if you draw a line segment from one vertex to the opposite vertex, this is called a diagonal. So this page 1 and 2 consists of all these quadrilaterals which you have learned before. But for now, what we need to do is that how do I prove that something is, for example, a rhombus or rectangle? So you need to know all these different properties of these shapes so that, let's say the question say that prove that this is a parallelogram, for example. What do I need to show in order to show that this is a parallelogram? So for example, if I look at parallelogram, right? A parallelogram has two pairs of parallel sides, and these sides they have the length are the same, equal and opposite sides, meaning that the length of each opposite side is the same. So what do I need to show in order to prove that something is, let's say, a parallelogram? Okay, so this is essentially what this whole worksheet is about. I'll leave you to read this for a few minutes. Make sure you read through the different conditions to show if something is a square or rectangle, rhombus, parallelogram, kite, or trapezium. I will go into example 1 directly to show that in this case over here, how do I show that this shape ABDT is a parallelogram? Okay, so let's look at example 1 after you have read through all the different properties of what makes these different quadrilaterals, the certain shape that we call them. So let's start with example 1. Okay, in order to show that ADBT is a parallelogram, we look at the information given from the question first. I know that given that BA equals to DT, meaning that I know that this side here is the same as this side, the length. Okay, and BE equals to ST, meaning that this length here is equal to this ST length. Okay, DE is perpendicular to BT, this is perpendicular to this line here, and AS is perpendicular to this line. Using congruent triangles first, prove that DT is parallel to BA, meaning that I want to show that this is parallel to this line over here. So what can I do? Okay, to show congruent triangles, over here based on this, I can see that I have right angles. I want to show that DT is parallel to BA. So therefore, since I know that using this perpendicular property over here, I know that the triangles I would probably need to consider would be triangle DET and triangle SBA. Okay, because once I show that these two triangles are congruent, I can therefore conclude that I can make further inference to show that the lines are parallel first. But let's start by looking at these two triangles first. Okay, so if I look at this diagram, right, since given that DE is perpendicular to BT and AS is perpendicular to BT as well, I know that this angle here is also 90 degree. Okay, so therefore I can conclude that angle DET is equal to angle ASB, and this angle is 90 degree. Okay, this is okay. Then after that, this is the right hand side. Now by congruence test, since this is a right angle triangle, we can use the RHS test. Next in the RHS test is I want to show that the hypotenuse is the same. So I know that this length here, the hypotenuse of the right angle, is equal to this length here, which is also the hypotenuse of the other right angle triangle. So therefore, okay, this is the R. Okay, therefore, ET, given that DT is equal to BA, okay, this is the next side. And the last one is to show that one more side is the same. So if I analyze the question here, we know that this line ET, which is one side of this triangle here, ET is made up of ES plus ST. Okay, this length here I want to show is made up of ES plus ST. Okay, and this since I know that ST is the same as BE, ES is equal to the ET equals to ES plus ST, and since ST is equal to BE, this is ES plus BE as well. And this length here, ES plus BE, gives us the length of SB. Okay, so therefore I can see that based on this property here, ET, the length is the same as SB. Okay, so therefore I can now I have shown another side of these two triangles is the same. Therefore I can now make the conclusion that therefore triangle DET is congruent to triangle ASB. This is by the RHS congruence test. Okay, so now that I've shown that these two triangles are congruent, I can now see that based on this, I know that these two angles, in fact, since these two triangles are congruent now, by congruent triangles, I know that this angle here is the same as this angle. Okay, so therefore, if I do this marking out, these two angles are the same by congruence. So the next part is that since triangle DET is congruent to triangle ASB, I know that angle, in this case angle DTE is equal to angle SBA. DTE, it should be ASB. ABS. What am I talking? ABS. Okay, so therefore, from here, since I've made this conclusion that these two angles are the same, therefore, if you notice, right, this is actually alternate angles, two lines, and then I have a line that joins them, and these two angles are the same. Therefore, we can go on, draw the conclusion that since these are alternate angles, therefore I can conclude that DT is parallel to BA. And this is the first part of the question which we are asked to find to prove that DT is parallel to BA. Okay, then the next part, hence show that ABDT is a parallelogram. So therefore, since I've concluded that since given by the question BA is equal to DT and BA is parallel to DT, therefore ABDT is a parallelogram. Okay, because to show that something is a parallelogram, I simply need to show that I have one pair of parallel sides, and then these parallel sides are the same. So to put this into perspective, this is shown. Okay. So to understand this better, let's say I have two lines. Imagine I have two lines. No matter what these two lines are, as long as these two lines are parallel and the length of these two lines are the same, if I form a quadrilateral from here, no matter how these two lines are shifted anywhere, as long as I draw two lines that connect them to form a quadrilateral, you'll notice that this will always become a parallelogram. So therefore, in this case over here, I just need to show that these two sides, opposite sides are parallel, and the length of these two sides are the same in order to prove that this entire shape is parallelogram. Okay, this is for example 1. Okay, let's look at example 2 now. For example 2, I'm given this quadrilateral over here. E, F, G, H are midpoints of these sides respectively, and this angle is given to be 90 degrees. Prove that E, F, G, H is a rectangle. So let's look at this. When I see a midpoint, right, usually it's a hint to tell you that you might have to use a midpoint theorem. So for this case over here, in order to show that something is a rectangle, we must first show that it's a parallelogram first, and then all the angles are 90 degrees. So let's start by how do we show that this is a parallelogram. Over here, you can see using the midpoint theorem, okay, since E are the midpoint of AB, so over here, E and F I know that I look at this triangle over here, okay, based on this triangle here, okay, I know that since BE is equal to EA and BF is equal to FC, because I know that these are the midpoints directly, okay, therefore by midpoint theorem, I can conclude that EF is parallel to AC. EF is parallel to AC, and this is by midpoint theorem. Okay, then afterwards, once I made this conclusion, I also need to I want to show that if I want to show this is a parallelogram first, I need to show that opposite sides are parallel. So I want to show that this HG is parallel to EF. And another way to do so is to also use the midpoint theorem for this triangle instead. Remember midpoint theorem, I always need to consider one triangle. So for this case over here, okay, since DH is equal to HA, okay, this is another case of the midpoint theorem. Okay, these two lines are the same. Okay, I use 3 lines to represent. Okay, so therefore, DH equals to HA and DG is equal to GC. I can now make the next conclusion that therefore HG is parallel to AC. Okay, and this is also by the midpoint theorem. Okay, and therefore this we can draw the conclusion that since EF parallel to AC and HG is also parallel to AC, therefore EF is parallel to HG. And therefore I've shown that these two sides are parallel. Okay, next part. Also by the midpoint theorem, I know that by midpoint theorem, I also know that EF is half of AC and HG is also half of AC. So if you recall the midpoint theorem, in this triangle over here, I know that HG is half of AC. In this triangle over here, I know that EF is half of AC as well by the midpoint theorem. Therefore, since I know that EF is half of AC, HG is also half of AC, therefore EF is equal to HG. Okay, and since from this conclusion over here, since I have shown that I have one pair of parallel sides and these parallel sides are the same length. Okay, so therefore since EF is parallel to HG and EF is also equal to HG, therefore EFGH is a parallelogram. Okay, then now my next step. Once I have shown that this is a parallelogram, now I want to show this is a rectangle. So given by the question here, since I know that this angle here is 90 degrees, and in a parallelogram, I can find these angles by corresponding angles. Therefore, this tells us that all four sides here, the angles must be 90 degrees. Okay, this will be, sorry, not by interior angles, because I know that these two lengths are parallel. So by interior angles, I know that all four angles must be 90 degrees. And therefore, I can make the conclusion that since EFGH is a parallelogram, and angle HEF equals to 90 degrees, I can therefore make the conclusion that therefore EFGH is a rectangle. Okay, so very simply we can therefore show that this, based on the properties of a rectangle is a parallelogram which the angles are all 90 degrees. This will show us that how to show that this quadrilateral here is a rectangle. Okay. Okay, so now let's look at the last practice question before you go back and finish up assignment question 2 and question 8. Okay, let's look at this practice question here. Before that, the last page of this worksheet, you can look at all the properties of all these different shapes. All these are very important properties to help you identify and distinguish between these different shapes. Okay, so this time you guys go back and read and go and make sure that you are clear on the different properties of these different shapes. Okay, then next one. Okay, Next one is the last practice question that I'll go through, which is this practice question here. Please go and try it by yourself first. After you have tried it, then come back to this video to check whether your answers are correct. Okay, so now I'll go through this practice question. Practice question, this one here, to make use of what we have learned about quadrilateral properties of any quadrilateral figures, how to use it in this chapter. So in this question here, I'm given that ABCD is a rectangle. Okay, angle ABE here is equal to this angle. Show that these two triangles are congruent. Okay, so very simple. For this question here, I can simply use the ASA test. These two angles are the same. If this is a rectangle, I know that this must be 90°, and therefore I also know that this side is the same as this side in a rectangle. So therefore, for part 1, okay, I'm looking at in triangle ABE and triangle CDF. I know that angle ABE is equal to angle CDF. This is given by the question. Next, the side. I know that AB is equal to DC. AB is equal to CD. Remember to match the vertices. AB is equal to CD, and this is because opposite sides of a rectangle ABCD are equal. Okay, this is the AS. Then the last one, the last angle here, I know that angle EAB is equal to angle FCD, and this angle here is 90°, and the reason is because these are interior angles of rectangle ABCD. Okay, this is the last angle A. Okay, so therefore from here I can therefore make the conclusion that therefore triangle ABE is congruent to triangle CDF, and this is by the ASA congruence test. Okay, this is for part 1. Part 2 now, I'm supposed to prove that this entire shape EBFD is a parallelogram. So how to do this proving? Okay, so I first look at it first. I know that in this rectangle here, I know that AD is equal to BF. Okay, so therefore, we can write that first as a statement. Okay, I know that AD is equal to BC. Should be AD equals to BC. These are opposite sides in a rectangle. AD equals to BC. This is the reason is because these are opposite sides of rectangle ABCD. Okay. Then from here, I know that AD is made out of two parts. AD is equal to AE plus ED. Okay. AE plus ED. And similarly, for this side over here, I know that this BC here is made up of these two parts as well. CF plus FB. And since I have shown in part 1 that these two triangles are congruent, okay, therefore, since triangle ABE is congruent to triangles CDF, I know that AE is equal to CF. Therefore, these two are the same. Therefore, hence, I know that ED is equal to FB. Okay, so I've shown that for this part over here, this length is the same as this. You must show that this length is the same through this method. You cannot just claim that they are the same without proper reasoning and proof. Okay, so for this chapter, it's very important to make clear how you show that these two lengths are the same, not by observation, but using the properties of the rectangle or the figure that is given. Okay, so now that I've shown that these two sides are the same, in order to show that this is a parallelogram, I just need to show that I have one pair of opposite sides, and this pair of opposite sides, the length is the same. So in this case over here, I've shown that the sides are the same. Next part is just to show that it's parallel. So in this case over here, also, I know that ED is also parallel to FB because in this rectangle here, remember opposite sides in the rectangle are parallel. So therefore, the reason is because AD is parallel to BC in rectangle ABCD. All the reasons must be stated very clearly because these are very important methods to show how you get your certain conclusions. Okay, and therefore, since ED is equal to FB, and I know that I've shown that ED is also parallel to FB, I can therefore make the conclusion that therefore EBFD is a parallelogram. Okay, and that's how I solve this part and this practice question. Okay, so once you're done, please go and finish up the assignment questions, 2 assignment questions only, assignment question 2 and assignment question 8, then submit it once you are done with these assignment questions. Okay, so that's all for this video on chapter 19 worksheet 3.